When we think of Rome, we think of the Colosseum. We think of marble statues and the paved roads that connected an empire. But Rome's greatest engineering feat isn't something you can see from the road. To find it, you have to go 80 feet underground into the harshest deserts of Jordan and North Africa. Last time, we looked at the sheer scale of Roman logistics, but today, we're looking at something that, on paper, should have been physically impossible for an ancient civilization. A secret 94-kilometer subterranean canal system that maintains a gradient so precise, modern lasers struggle to replicate it. They didn't just move water, they made it flow uphill. They built a CERN-level megaproject in the middle of a wasteland. This is the secret hydraulics of the desert. This is Gadara. 2,000 years ago, it was a crown jewel of the Roman East, but it had a problem. It was high, it was dry, and it was surrounded by 50,000 thirsty citizens. The Romans didn't just build a local well, they launched the Fir'aun, or the Canal of the Pharaohs. But don't let the name fool you, this was pure Roman grit. At 94 kilometers, this is the longest tunnel of antiquity, but the length isn't the baffling part, it's the gradient. To keep water moving via gravity over 60 miles without it stagnating or moving so fast it eroded the stone, the Romans had to maintain a slope of exactly 0.3 meters per kilometer. That's a 0.03% incline. If the engineers were off by just a few inches at the start, the water would never reach the city. Yet, they carved this through solid limestone, underground, in the dark, using nothing but oil lamps and hand chisels. How did they do it? They used a technology called Qanats. Instead of digging one long tunnel from either end, which would have taken decades, the Romans used vertical access shafts. They would dig a hole straight down every 20 to 50 meters. This allowed them to work in parallel. It turned a 100-year project into a 10-year project. But it created a new nightmare: alignment. Imagine 500 different teams digging toward each other in the dark. If you're off by even a degree, the tunnels don't meet. We find correction marks in the Gadara Aqueduct, where Roman engineers realized they were drifting and adjusted their course. This wasn't just digging, this was high-level geometry performed in the mud and the heat of the Jordanian bedrock. But then they hit a valley. Usually, Romans built those iconic arches, the bridge aqueducts, but sometimes the valley was too deep, the wind was too strong, or the ground was too soft for a bridge. So the Romans did something that modern experts still study today. They used an inverted siphon. Physics 101 says water finds its own level. If you trap water in a sealed pipe and drop it down a hill, the pressure generated by the fall will push it back up the other side. But here's the catch. At the bottom of these valleys, the water pressure was immense. We're talking 15 atmospheres of pressure. The Romans didn't have steel. They didn't have arc welding. They used stone blocks bored through the center and sealed with a mix of lead, oil, and lime. If one seal failed, the entire system would explode like a bomb. Yet these siphons moved millions of gallons of water uphill, day and night for centuries. Why does this matter in 2026? Because we live in an era of disposable infrastructure. We build bridges that last 50 years and roads that need repair every 5. The Romans built for the eternal city. They didn't just want to solve the water problem for their generation, they wanted to solve it for the next 1,000 years. By hiding their most vital infrastructure underground, they protected it from the sun, from evaporation, and from enemies. The secret hydraulics of the desert are a reminder that the most powerful technology isn't always the flashiest. It's the stuff that works silently, invisibly, and outlasts the empire that built it. We've decoded their roads, we've mapped their tunnels, but we're still trying to capture their mindset, the belief that a project worth doing is a project worth making impossible. Next time, We're going to look at the Roman mega harbors, the concrete that actually gets stronger when it hits seawater. You won't want to miss it. Subscribe to keep exploring the Roman legacy. I'll see you in the tunnels.